The first topic that we look at in this unit is a radical function, in that what happens to a graph when you put a graph inside of a square root. That's basically the idea that we're going to be looking at. We've already done the square root of x, and that was one of your parent graphs, and you knew how to graph it, and you knew how to do all the transformations of it. What we're going to look at is what happens if we put anything inside of a square root. What happens if you took the square root of a parabola? What happens if you took the square root of a sine graph or a square root of a log graph? What are some of the common features, and what changes and what stays the same? So the key to this, and the place that we start, is we start looking at the function inside. So here's one that you already know. You already know how to graph the square root of x plus 4. You would have taken your square root graph and moved it 4 to the left. Perfect. But now we're going to look at a different way of graphing the same thing. If you knew what the inside graph looked like, so that they've that graphed here in red, x plus 4. It's a straight line, right? And then you think about, well, what are the properties of square roots? I can't take the square root of a negative. What are some square roots that you know? You know the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2, and so on. And so a key thing that happens in your graph is, since the square root of 0 is 0 and the square root of 1 is 1, those are values that don't change. In fact, those are the two values labeled in red. If the inside graph is equal to 0, then the square root would still be 0. If the inside graph is equal to 1, then the square root would still be 1. Does that make sense? And so these 2 points, here and here, are sort of going to be a starting point for us. And then you might find other points that you know. For example, on your red graph, there your y value is 4. What's the square root of 4? 2. So you can, if you know points on your original graph, you can find some points on your square root graph. Now, some other interesting things happen with square roots. Generally, if you take the square root of a number, is your answer bigger or smaller than what you started with? Like if I do square root of 9, I get 3. It's smaller, right? If you do square root of 100, you get 10. It's a lot smaller. Probably if I asked you, if you take the square root of a number, you would almost always say it's smaller. Because your brain automatically goes to whole numbers, right? 0 and 1 is where it stays the same. But if you did the square root of 9, it's 3. Square root of 25, it's 5. You're saying that it's smaller. But in reality, that only accounts for this section of your graph, when values are bigger than 1. If you take out your calculator, what's the square root of a quarter? 1/2. What's bigger, a quarter or a half? A half is bigger. Same thing, like 1/100. You get 1/10. It's bigger again. In fact, if you take the square root of any number between 0 and 1, your answer is always bigger than what you started with. Here, I'll show you an example of a random one. Square root 0.0269. Okay? Look at my answer. Is it bigger or smaller than 0.0269? Answer is 0.16. My answer is bigger. Anytime you do the square root of something between 0 and 1, 0.9, enter, 0.95. It's bigger. So when we look at our graph, in this little section between 0 and 1, where your y values on your original graph were between 0 and 1, your blue graph, oops, that's not blue. Try that again. Your blue graph is slightly above your red graph. And so if you turn to the next page and take out your highlighter or your textbook highlights these key characteristics. Characteristic number 1. If you have 0 and 1 for y values, those points don't change. That will always be a key with this new technique for graphing square root functions. You'll graph the function inside and say, are there any places where the y values are 0 or 1? Because if they are, the square root of 0 is 0, square root of 1 is 1. Second point. If, okay, and I'm going to highlight this, but I'm going to if your y values are between 0 and 1, your square root graph will be above the original graph. The second one, if the y values are bigger than 1, then the square root graph is below. And the last point, it says, if the graph of f of x is below the x-axis, in other words, if your y values are negative, then your square root graph won't exist. Now in each of these, I'm talking about the y values of the function inside. So we have y values for our square root graph, and we have y values for the function inside. What we're going to be doing for this new technique is graphing the function inside and then using these 4 points to help us graph a new function. And these same rules apply for whatever graph you have. So here's our first example. They have just given us the graph. So we don't know what the equation is, but we know what the original graph looks like. So in other words, they've tried to make this even easier for us. Because normally, when trying to sketch the square root of f of x, you would graph, step 1 is graph f of x first. That's already done for us. And now we have to use those 4 ideas to graph the square root graph. So we look at the y values on f of x, and wherever the y values are 0 or 1, those aren't going to change, because the square root of 0 is 0, and the square root of 1 is 1. So here, on the first graph, we look. Are the y values ever 0? Yes, right there. Are the y values ever 1? Yes, right there. So step 1, I would always recommend, okay, if we were to write steps here, I'm going to make it a really ones that you can do the square roots of. Plot your nice points first. 0 and 1 are the most important. But do we have any other nice points on here? Yeah, we have 4. What's the square root of 4? 2. The x value doesn't change. Doesn't really look, well, technically, would you say that this is 9 right there? So if we went straight down from 9, it should be 3 when we take the square root. Step 1, plot whatever nice points that you have. Okay. Step 2, and step 3 are sort of the same thing. On your original function, if your y values are between 0 and 1, you have to graph your square root function slightly above. Maybe it's even good to write slightly and spell it right. Slightly. Just a bit above. So what would that look like here? There, slightly above. By above, I mean going up and down. Can you see that the blue line is higher than the red line? And then when y is bigger than 0, it has to be below. Well, if you did other nice points, that part's going to naturally be below. It's not really a step, but wherever the original graph is negative, your square root graph doesn't exist. Okay? So do you see that my graph isn't going to go further to the left? It's going to start at 0, but these points where the red graph has negative y values, you can't take the square root of a negative. Technically, we're done our graph here. Now for step 2, you have to be careful. So I'm going to show you a couple examples of where step 2 goes wrong. Okay, I'm going to erase between there and there and add this dot. Okay. Here I'll do it in purple so you know that it's wrong. Well, whatever I do in purple would get a half a mark taken off. Okay. Not slightly above. Okay, it had to come back down again. In fact, it should never go above y equals 1. Because the square root of 1 is 1, anything below that. So this would be too high. Next one, that's wrong. Okay? It seems slightly above, but can you see that it's gone backwards in time a little bit? My graph went into, like, past -2 there for a second, then came back in. So that would be also considered wrong. Sometimes the best you can do is almost right on top of the line. Just try to make it slightly above. But that's a place where they're really going to be picky on how you've drawn it. But other than that, those steps remain the same every single time. Your nice points, always going to have 0, 1. That's the only nice points I have on this because it never gets to 4. If I would estimate, if I would extend it, could you see that sort of can estimate that it would get to 4 at about there? When your y values on your original graph are between 0 and 1, it's got to be slightly above. And then after 1 below. Now these new steps work for any graph. So we did lines first. I'm going to get you to practice. You can try number 5 with some more lines, but then we're going to look, it works the same with parabolas, works the same with cubic graphs or sine graphs or log graphs.